Warning: sodium metal is extremely reactive and may ignite spontaneously when heated. Molten sodium hydroxide is extremely corrosive. This experiment involves extremely high temperatures. Wear safety gears properly and do the experiment outside. Hi guys, here is MIH. I have recently been doing a bunch of molten salt electrolysis, including the video I posted about making lithium from molten lithium chloride. However, lithium is not really the best choice when making reactive metals, since lithium salts are extremely expensive and lithium is somewhat unreactive compared to other metals. Therefore, the single bullseye of molten salt electrolysis is to generate sodium metal, which is exactly what I'll do today. I will be electrolyzing molten sodium hydroxide to make sodium metal. Besides this, I was also experimenting with molten sodium chloride and received partial success, but it is not yet ready to be posted as a video until I get a different success run, so you can anticipate that later. Here's an overview of everything that I used. An electric heating device for melting tin is used as a crucible. The anode was a stainless steel rod and the cathode was a thick iron wire. It is encased in a stainless steel tube but not touching it, and insulated from it by some Teflon tape. I planned for this tube to act as a shelter and prevent the sodium from reacting with the air, but later on I found that it doesn't really work very well and got rid of it. I filled the cell with a bunch of solid sodium hydroxide and switched on the heating. Within 1 minute, the sodium hydroxide started melting. I stirred it around with an iron rod to help it melt faster. When nearly all the sodium hydroxide melted, the electrolysis started. Here you cannot see a current display because my power module only works properly in higher output voltages, but there are certainly a lot of gas released on the electrodes. A few minutes later, we can see a molten glob of sodium metal around the iron rod cathode. It is growing bigger and bigger. The current was running steadily at about 4.5 amps. A bunch more sodium is generated within a few minutes, and I attempted to scoop the sodium out. I first prepared a beaker of mineral oil and a copper combustion spoon. Then the electrodes were removed and the spoon was lowered into the sodium hydroxide melt. With some effort, I managed to squeeze the sodium glob to the side and scooped it out. I then placed it in the mineral oil for storage. Over the course of 15 minutes, I kept removing the sodium produced from the cell. It was sort of difficult to spoon out the sodium since the surface tension of molten sodium hydroxide is quite high, so the sodium moves to the sides of the container and easily slides around, making it very hard to scoop. After about an hour, the production rate slowed down considerably, and the sodium did not fuse into a single globule, but instead dispersed as a few smaller balls, making it easier to oxidize and burn away. I'm quite tired as well, so I decided to stop the cell and take everything apart. I then put my beaker of sodium covered in mineral oil on a hot plate and tried to coalesce all the sodium together to one bead. A while later, the sodium did melt, but there was just too little sodium compared to the sodium hydroxide slag, so it didn't fuse together. I then tried squirting in some ethanol. A large portion of it boiled away directly, and the rest was reacting with the sodium to release some hydrogen. However, the sodium still didn't stick together. After having a terrible oil spill accident, I just decided to manually pick out all the sodium pieces with a tweezer, and here is our final yield of sodium metal. It wasn't very much, but considerably more than the lithium we got last time, and it was decently pure without a lot of oxides. I then went on to dispose the sodium hydroxide slag left inside the beaker. When I add water to it, the leftover sodium started reacting with it and it was quite interesting to watch. The sodium melted into a ball and traveled on the surface just like what the textbooks say. Overall, I am pretty satisfied with this first trial of making sodium from sodium hydroxide. I did get a decent yield, and I didn't encounter too much danger in the process. The cell definitely could be improved, but again, this is a test run and I think I did a decent job on this project. See you next time!